Hey everyone, welcome back to this Unreal Engine 5 tutorial on creating a robust modular stamina system that can be attached to any character as an actor component. In part 1 of this tutorial, we created a simple UI element, then created our stamina component and set up some sprint functionality for our character. In part 2 of this tutorial, we will create the Stamina Cycle Manager function, which will handle all of our stamina drain and regeneration. There will also be quite a few functions within this main function that we will create in order to achieve this. After we've created those functions, we will then update the code in our UI so that our progress bar reflects the changes in our character's stamina levels at runtime. If you'd like to get access to the project file for this YouTube tutorial, you can download the UE 5.4 project file completely for free from my Patreon. I'll provide a link in the video description. It's completely free, you don't need to sign up or anything. And with that out of the way, let's begin. So now that we've got our start and stop sprinting functions, we're going to work on the actual stamina cycle itself. So we're going to need a new function and we're going to call that Stamina Cycle Manager. And we're going to need two inputs in our function. The first is going to be a reference to our movement component. So we'll add an input of type movement component. Where are we? Component. So the character movement component, object reference, and we'll just name that character movement component. And the next input is going to be a reference to our sprint speed. So that will be of type float, and we will call this sprint speed reference. Compile and save. So the first thing that we need to do is we need to check if the character is actually sprinting so that the function knows whether to drain stamina or whether to regenerate stamina. So we're going to create a new function here, and we'll call that get currently sprinting. And I'll just drag this out onto the event graph here, and we're actually going to turn this into a pure function because it's not actually going to be executing anything or changing anything within the game. We're just getting some information and passing it on. So I'm going to change this into a pure function by clicking this button here. And what we need to do is we need to pass in a reference for the character movement component and the sprint speed reference as well. So if we highlight our function and type in an input here of type character movement component, object reference, maybe I'll just copy the name, make it a bit easier. And the next will be type float, and we'll copy this name here as well. Compile, save, and then now what we'll do is we'll just hook these up. Perfect. Now we also need to set an output as well. So we need to return a Boolean variable to return whether or not the character is sprinting is true or false. So we'll add an output of type Boolean and simply name this currently sprinting. Compile, save. Now we'll double click the function to go inside it, and let's set up our logic here. So to do this, all we need to do is we need to drag off the character movement component and type in get last update velocity, and then we'll type in get vector. Not get vector length, it's just vector length. And I'll explain why we use the vector length node in a minute, but for now, we'll just drag off the end there and type in the greater than symbol. And now what we'll do is we will drag off the sprint speed reference and we'll type in a minus symbol, so subtract. and then we will add the number 5 here, and I'll explain this in a moment, but for now we'll just hook this up like so, and then we will hook our Boolean up to the is currently sprinting. Okay, so what's happening here? So I mentioned I'd explain what this vector length was. So normally a vector will actually output 3 values, one each for x, y, and z. That makes up the vector, but we don't want 3. We just want the 1. So the vector length basically takes that vector and converts it into a more easily manageable single float. And then what we're doing is we're checking to see if the last update velocity of our character was greater than our sprint speed minus 5. So if you remember earlier, we set our sprint speed to 500. So here we're basically just checking if our velocity is currently greater than 500 minus 5. Future Stephen here, I'm realizing now that I probably didn't explain very well why I did this. The reason I'm checking whether or not the current velocity is greater than our sprint speed minus 5 is because I want to control for edge cases where the character's velocity isn't exactly equal to the sprint speed. It's never really been much of a problem, but I've found that sometimes relying on precise numbers can be an issue. So I've basically created a small margin of error of 5 units, hence why I'm checking whether the velocity is greater than sprint speed minus 5. Now we'll get back to the tutorial. So we'll close this function and we'll go back to our stamina cycle manager function. And the last thing that we need to check is whether or not our character is actually on the ground, because maybe our character is actually moving at our sprinting speed, but maybe that's just because they're falling. So we don't want the stamina to drain while the character is not actually physically on the ground and running. So that is fairly easy to check. All we need to do is we need to create another function again, and we will call that get is on ground. Compile and save, and we'll just go back to the stamina cycle manager for a moment and drag that onto the event graph. And we'll also, again, because we're not actually changing anything within our game, we're just getting some information, I will change this to a pure function as well. Now for this particular function, we only need one input reference, and that is to our character movement component. So we'll click in input once, and we'll make that of type character movement component object reference. And again, I'll just copy the name here from the other function, enter, and we will hook that up like so. And we also need a Boolean output to return whether or not on the ground is true or false. So we'll click our output once, change that to type Boolean, and we will call that is on ground. Now we'll double click on our function here to actually input the logic. So this is actually pretty easy. All we need to do is drag off of character movement component and type get last update velocity. And what we're going to do here is we're going to drag off the output and type in normalize. And it is the first one here. So what the normalize function does here is it takes this vector output here and converts it into a number between 0 and 1. Now the reason why we're doing that is because if we right click on this return value here and click on split struct pin, we get access to our individual float coordinates here, so the x, y, and z value. So if we're trying to determine whether or not our character is on the ground, we're interested in the z value here. And what this normalize function does is it converts the z value into a float value between 0 and 1. So 0 means that the character is on the ground, and then any number above absolute 0 means that the character is elevated off the ground. So to determine whether or not the character is on the ground, we just output from the Z value here, type in equals equals. And if it equals to 0, then that means that the character is on the ground or running on a surface. And then we can connect that up to our Boolean is on ground, and that is it. So we can close off that function there and go back to our stamina cycle manager. And so now that we get access to the whether or not our character is sprinting and whether or not our character is on the ground, we just need to combine those into a Boolean branch. So if I drag off one and type in and bool, and we want the top one here, and bool, not the NAND bool, and then hook is on the ground up to that as well, and then output from the and Boolean and type in branch. And we will connect up to that, to our stamina cycle input execution there. And then what I'm going to do here, just to tidy things up a little bit and make it look a little bit nicer, I'm just going to highlight all of this, right click, and then select collapse to macro. Okay, and then I'll call this macro stamina drain or regen. And now we'll just double click on this macro. And you might be wondering why I decided to make this a macro instead of a function. And that's because a macro can have more than one execution output. So if I select on the output here and then change this to exec, rename this one stamina drain, I can add another execution output and then rename this stamina regen. So if get currently sprinting and get is on ground is true, then we drain stamina. If either one or both of those are false, then we regenerate stamina. If we compile and save, and we close that macro. And now we've got this macro, and I just realized that it's actually created 2 inputs for character movement component. We actually don't need that, so I'll just alt-click on one of those, double-click, and I will alt-click on that one there, and then just hook that up to there as well. And I will delete the one that we don't need, compile and save. So now I've got this neat and tidy macro to check whether or not we need to drain stamina or whether or not we need to regenerate stamina. So now that we can actually check whether or not we need to drain or regenerate stamina, let's set up the functionality to drain stamina. So what we're going to do is we're going to create a new function, and we will call this drain stamina. Enter, compile, save. We're going to create a new variable of type float. And we're going to call this current stamina. And we also need to know what the max stamina for the character is going to be. So we'll add a new variable of type float, and we'll call this max stamina. And then finally, we also need to know the drain stamina amount. So we need to create another float. We'll call it drain amount. And now, just to keep things very modular so that you can use this with any particular character and not have to worry about changing the float variables in here, what we'll do is we'll actually just go back to our event graph in the BPC stamina system, and we'll go back up to this setup initial references here. And what we'll do is we will add a new input to this event as a float type variable, and we will call this max stamina, because maybe different characters that you make will have different levels of stamina perhaps. And then back in our character blueprint, now that we've got this extra input here, we can either hard code it in ourselves as 100, or you can even promote this to a variable if you wish. I'm just going to hard code it for now as 100. And then from here, we will set the max stamina like so to the value that we've just input from the character class. And then we'll also use that value to set the current stamina as well. So that means that we are setting both the max stamina to 100 and the current stamina to 100 as well. Now back to our drain stamina function. Now that we've got our variables set up, first thing we're going to do is we're going to get our current stamina, so get variable, and subtract the drain amount. Now we haven't actually set a default drain amount yet. I'm going to set the drain amount to 2. So it means that every time this function executes, it's going to drain 2 from our current stamina, and we'll hook that up there. So current stamina minus the drain amount, which is 2, and we're going to clamp this. So, and we want to clamp float. So we're going to clamp it to a minimum of 0 and a maximum of our max stamina. So this just makes sure that our stamina never goes below 0 or over our max stamina amount. And then finally, we're going to use the output of this to set our current stamina. So we drag off current stamina and select set, hook that up, and then hook the execution up like so. Now this is essentially all you need in order to drain stamina, but we also want to provide feedback to our UI. That's the progress bar we made earlier, so that it knows that every time stamina is drained, we also update our heads up display to reflect the drop in stamina. So what we're going to do is I'm just going to create a new function again, and I'll call this get stamina percentage, and I'll add a float input to this and call this raw stamina. And then we want to get the raw stamina and divide it by the max stamina. So in this case, if our stamina was 50 and we divide it by our max stamina, the output would be 0.5, but we want to change that into a percentage. So we'll do multiply by 100. Now, I know it may seem a little redundant to divide by 100 and then multiply by 100. You're effectively not actually changing anything. But this is in case you have an instance where a character actually has more than, like, their max stamina is actually, the value is greater than 100. So maybe the character gets a power up and now their max stamina is now 120. In order to convert that into a percentage, we need to divide it by the max stamina and then times it by 100. So that's why I've done that. And then finally, we need a return node. And we need 2 values here. We need a text value and a float value. The reason being is because in our stamina bar, we have a number and we've got a progress bar. So the number is going to be raw text and the progress bar is going to be a float percentage. So we'll add the first output, and that will be of type text. And we'll call this stamina text. And then we'll add a second output as type float, and we'll call this stamina percentage. So in order to get the stamina percentage, we can just output from this divide node here. And then to get the stamina text, we can just connect these two up and it will create a converter node which converts the float into normal text. Tidy this up a bit. So quick review, we're getting the raw stamina, dividing it by the max stamina, and that gives us our stamina percentage. And then to get the stamina text as a whole number that displays on the screen, we take that output and times it by 100. So for example, 0.5 times 100 equals 50. Convert that into text, and then that will show up as the text 50 on our heads up display. Compile and save. And if we go back to our drain stamina function and drag in our get stamina percentage function, we can change that into a pure function, and we'll hook up that raw value to that function there. But now, in order to update the UI, we need to make use of an event dispatcher. Now, if you haven't used event dispatchers, or you're not too familiar with event dispatchers, I'm not going to go too deeply into it, but there's an excellent video on YouTube by a guy named Tyler Sereno. I highly recommend watching this video if you want to learn a bit more about how event dispatchers work. But for now, I'm just going to add an event dispatcher down here by pressing the plus button, and I'll call this call update stamina. And then we can drag this event dispatcher onto the graph and then select call to call the event dispatcher, hook that up, and we need a couple inputs so that we can pass on this information to the UI. So what we'll do is we'll highlight the call update stamina event dispatcher, and then over here in the top right under the details panel, there's an input section. If we click this plus button here where it says new parameter, and now we will change the type to a text and call that stamina text, and we'll add a second input of type float and call that stamina percentage. Compile. Now, it's not liking this for some reason, but I'm fairly sure that if we just delete it and then drag it out onto the event graph again, there we go, it's fixed. So I'll just hook that back up again and then connect the stamina text and the stamina percentage, just like that. Finally, I'll just add a return node. Now, we have called this event dispatcher, but we need our widget to know that it's being called. So what we'll do is we'll just go to our content drawer, go back to our UI folder that we created earlier, and then open up WBP_stamina bar. And now in our event graph here, what we need to do first of all is we need to right click and then type in get owning player pawn. And then from there, we need to cast to BP third person character. And we're not going to do it on pre-construct. What we're going to do is we're going to right click and select event on initialized, which is only called once when the widget is initialized, and we will hook that up like so. Compile and save. And now what we'll do is we just need to check if this reference to the character is valid. So we'll type in is valid and select the one with the question mark. And if our reference is valid, then what we'll do is we'll get a reference to the BPC underscore there it is, BPC stamina system down the bottom under default, and we will promote this to a variable. Call that pawn stamina component. Compile and save. Now that we've done that, we will go down to our event construct here. Future Stephen here again. If you happen to notice that your event graph doesn't contain the event construct node, or if you accidentally deleted it, simply go up to the My Blueprint panel where it says Functions and select this drop-down that says Override. And from the drop-down, select Construct, and the event will be re-added to your event graph. And we will drag off our pawn stamina component and select a Get node. And what we'll do is we'll just right-click this node and then convert it to a validated get. Okay, so what that means is that it's still getting a reference to the component, but it's not going to execute anything if this reference is not valid. So it's very similar to an isValid node, but just turns the get node into its own isValid node. So now that we've got a reference to the pawn stamina component, what we'll do is we will drag off the output pin there and type in bind event to call update stamina, which is the event dispatcher we just called. Drag off from the event pin, and you can add a custom event here, but because we're going to add a few of these bindings, what I like to do instead is drag off the pin and instead select the event dispatchers drop down and click on create event, because then what you can do is you can select this drop down here and select create a matching event, and then this will create an event that is bound to call update stamina. So I'll rename this to update stamina, compile and save. And then what we will do is we will get we didn't actually name our text bar from earlier, so I will select the text block here and just rename this into stamina text, and then I'll select the progress bar and I'll rename this to stamina percentage. Actually, I'll name it stamina percentage bar. Compile and save. Go back to our event graph and then select the stamina text, drag that out onto the graph, and then from there we want to set text down the bottom under widget, hook that up to the execution pin, and then from stamina text to from the stamina text to in text. So that'll update the number itself. And now we want to update the stamina percentage. So we'll drag off the stamina percentage bar and type in set percent. Hook that up to the execution, and then hook our stamina percent up to in percent. Okay, so now what will happen is that because this event here is bound to the event dispatcher that we created in our stamina system, every time this event dispatcher is called, it is going to update the stamina number and stamina percentage bar in our widget as we're playing. Go back to our stamina system here, and we are finished with the drain stamina function. So let's close that, and we'll go back to our stamina cycle manager function. And off the drain stamina execution pin, I will drag off the drain stamina function onto the event graph and hook up the execution like so. Now we're going to stay with the drain stamina logic for now. So after we've drained the stamina, what we'll need to do is we need to check whether or not our stamina is full. So for that, we can just drag off our current stamina variable, select get, equal, and is it equal to our max stamina? And if it is, then that means that our stamina is full. So we will select drag off onto a branch. And just to tidy things up a little bit, I'm going to collapse this into a pure function, which I will name get stamina full. And we actually want to check if it's not full, so I'll just drag off from here and type in not to access the not boolean, and then hook that up to the branch like so. So now if get stamina is not true, we will continue on with the logic, and I'll actually create a new variable here of type boolean, which I will call drain cycle started. And I will drag that off as a set node, hook that up to true, and then mark the Boolean value as true. And then from there, we need to check whether or not our stamina has actually been fully depleted, so we know whether or not to trigger the exhaustion event. So I'm going to get our current stamina and do a less than or equal to 0. And if that is true, then stamina is depleted. And I'm just going to collapse this into a pure function as well, just in case we want to call this again later, and I'll call this get stamina depleted. Compile, save. So if our stamina is depleted, we will set our is exhausted boolean to true. And that is essentially the logic for draining stamina. I will be adding a couple more things after this in a moment, but that is essentially how the draining stamina works. Now for regenerating stamina, because a lot of our functions have already been created, this will probably be a bit faster now. So I'm going to create a new function again, and I'm going to call this regen stamina. And in this function, I'm going to get the current stamina and add a regen amount. So we actually need to create a new float variable, and we will call this regen amount. Now I want the regenerating stamina to be half the speed of draining stamina. So if you remember before, we set our drain amount to 2. So I'm going to set our regen amount to 1. And I'm going to bring that onto the event graph and hook that up to there. So current stamina plus regenerate amount. And again, we need to clamp that. So select clamp float, and we need to clamp it between a minimum of 0 and a maximum of max stamina, like so. And then that will set. So if we drag off from that output there and type in set current stamina, and then hook up the execution pin. And again, we need to update our UI again with our event dispatcher. So I'll just drag that out and click call. Hook the execution pin up like that, and we've already created our get stamina percentage function from earlier, so I'll just drag that out again, hook up the raw value, and then hook up the text and percentage values like so, and then finally add a return node. And that is our regenerate stamina function complete, so we'll close that off, and then we can just drag regen stamina out onto the event graph and hook up from the output of our macro like so. And we also want the regen stamina to stop once our stamina is full. And we also need to check that our character is not currently sprinting. So what we'll do is set up another branch node here, and we'll get our get stamina full function that we created earlier. And then from there, we will add an and boolean like so. And then from this input here, we'll type in a not boolean. And we want to make sure that the character is not currently sprinting. So we'll get our get currently sprinting node from earlier and then hook up like so. And of course, we need the references to our character movement component in our sprint speed reference here. So we'll just add those from the start of the function input like so. So now this branch will check whether our stamina is full and not currently sprinting. And if both of those conditions are met, then we will set our is exhausted variable to false. Now we're almost finished with this function, but there's a couple things we need to do. So here we've confirmed that the character is exhausted, but then what do we do with that information? So if we go back to our stamina system event graph, you remember that we created this start stamina cycle event earlier, which is triggered from within our start sprinting function. So what we're going to do is we're going to drag off from there and type in set timer by event. For time, we want to specify how often this timer is going to re-trigger itself. So I'm going to put in 0.1. So that means that every 0.1 second, this timer is going to trigger the event associated with it. So what we'll do is we'll drag off from this event pin here, and we will select add event and then add custom event. And this one we'll simply call start stamina cycle manager. And then this is what will trigger our stamina cycle manager, the function that we created. So we'll hook that up like so. And then of course we need to pass in our values. So we will get our character component our character movement component and connect that up like that. And we'll get our movement speeds and then right click the output pin and select split struct pin. And we'll hook sprinting up to the sprint speed reference like so. And also something I forgot to mention is that we just need to make sure that looping is checked on the timer so that it will continue repeating the execution in a loop. So now if we press play and we've got our walking speed and we run and the stamina is draining as it should, and we release and it starts regenerating. If we run into a wall and we're not moving, so we're not currently sprinting, then the stamina will start regenerating. If we jump or if we're falling, then the stamina will regenerate even if we're holding down the left shift key. So this is all working exactly how we want it to. So let's recap. We successfully created the Stamina Cycle Manager function, which serves as the heart of our stamina mechanics. Within this main function, we implemented several key sub-functions to handle stamina drain and regeneration. We then updated our UI code to reflect real-time changes in the character's stamina levels. Our progress bar now accurately visualizes the current stamina value, providing immediate feedback to the player. With these core mechanics in place, our modular stamina system is now functional and almost ready to be integrated into various character classes. In the final part of this tutorial series, we'll add code for when our character becomes exhausted, requiring a cooldown period before she will be able to sprint again, and we'll also add some finishing touches to our stamina progress bar to give visual feedback to the player when the character becomes exhausted. As always, if you enjoyed this tutorial and found it helpful, please like the video and consider subscribing for more Unreal Engine 5 content, and I'll see you in part 3.